Hey guys, welcome back to SWAT Studes. I'm here with another tutorial. In this tutorial, I'm going to explain all the attributes of Arnold area lights in Arnold render for Maya. That will include all the basics from move, rotate, and scale to the Arnold attributes, and then finally the light filters available in the area light. I'll be explaining each attribute of the light in detail, what is it and how it is used. As you know, we have two area lights in Maya. One is the default area light and the other is the Arnold area light. Although 99% of the attributes are the same, we'll look at the only differences between them. And as you know, most of the attributes are common with other lights as well. So I'll be explaining all those attributes in detail on this particular tutorial so that I don't have to repeat it when I am doing the same with other lights in the upcoming tutorials. And one other important thing is that some of the fundamentals of some attributes are already been explained in detail in the past tutorials on the channel. So I'll be mentioning those tutorials for you to refer when I'm talking about them. So it's important that you check those out as well if you need to know more about those in detail. So the area light is one of the light that is far more used in lighting than any other light, or it is the case in my workflow. I use it more often because it has the ability to mimic any other light in the real world, almost all the lights. And also it has some unique features compared to other lights when it comes to doing the lighting. And so we'll look at those in detail. But since it is a demo of the attributes, we'll be doing it with a simple scene. And if you want to get more familiar with the attributes and their full potential, it's important that you use it in your personal works more often. The more you use it practically, the more you learn its possibilities. So let's get into the tutorial. So here I have this simple scene, and you can see I have already set it up with the ground plane, two spheres which has the same shader so that we can compare these two. And I have another plane which is blocking one light's information which should not be coming into the another light's sphere. And I have two area lights. One is the Arnold area light and the other is default Maya area light. We'll start with from where we create these lights. So to create a Maya area light, you go to the create menu, lights, and then click on the area light option. If you want to create an Arnold area light, that is AI area light, you get to go to Arnold menu, lights, then select area light. So let's just select the default Maya area light, and you can see the attributes here. Let me just copy the tab so that you can compare this with the Arnold area light. So if you see here on the first options itself, there is some differences. In the default area light, you have this option to choose or change the light to any other default lights. Arnold area light doesn't have that. And first thing is the color, which is similar, intensity, which is similar. Exposure is not visible here because it comes under this Arnold options. So from there, most of the attributes are similar, except for the fact that Arnold area light has this light shape attribute. So we'll look at this in detail further in the tutorial. So I'm just showing you the basic differences that you can see here. So the attributes which is only visible in the default area light, which is the first options here, which is emit, diffuse, emit, specular, and then decay rate, normalize, and legacy intensity. Most of this doesn't work in Arnold, especially the decay rate. The rest of this emit, diffuse, emit, specular will work in the Arnold render, but Arnold render has particular options like these sliders to adjust the diffuse and specular and more attributes. So we don't usually use these attributes in Arnold. We don't have to. And the decay rate doesn't work in Arnold. So if I want to explain the decay rate, what it is, if you place a light in the real world, when the light travels from the light source to any distance, the energy will reduce the more it travels, and the brightness also will reduce of the light. So there will be a change or a fall off in light uh, intensity from the light source to a particular distance. And when it reaches a certain point, there won't be any light visible. So this decay is what it's mentioned here as decay rate. So in the default Maya, there are a lot of different decay rates which won't work in Arnold render. It will only work when you use a Maya default render, which is software render. And we are not going to look at that now because we don't need it. And if you want to adjust this decay, we have light filters for that. So let's start the lighting with the default settings, which will be intensity 1, color 1, and the exposure 0. So again, I'm copying the tab here, and let's just do a render now. So by default, with the intensity of 1 and color value of 1 and exposure 0, we don't have enough light. So if I increase the intensity, let's say 10, you get some light. Let's do the same thing on the Arnold light as well. So it should be similar, but let me see what's the difference here. Okay, all the attributes here are similar, and we have putting the similar values here, but still we have difference in the light. Okay, I had to recreate the scene because the lights seem to be having some issues, so I just recreated both the lights again, and you can see now we have all the attributes similar. Like I have put intensity of 100 on both the lights and they are looking completely similar. And the light intensity is controlled by color, intensity, and exposure together. And I have an extensive in detail video about how the light intensity in total works with what is color and intensity and exposure, and what is the main difference between intensity and exposure. All of those things have clearly in detail explained on that video, which you can get it on the screen right now, and I'll put the link in the description. Also, you'll get on the top right corner the link, so make sure you check that out to see what's the difference between changing each attribute and what the results are. So you can increase the intensity or brightness of the light by changing the intensity or the exposure. Let me just put an exposure of 1, and let me do the same here. So the main difference between intensity and exposure will be that intensity is a linear value, which if I put 100, it means 100 units. But in the exposure, since it is an exponential value, which means if I put a value of 2, it means 2 to the power of 2, which will be value of 4 in the intensity. So if I want to mimic the same value of 100 with the exposure, let me just screenshot this. And if I put an exposure, an approximate exposure, which will be, let me put it back to 1, and let me just put a 7 to check. So it will be a bit brighter because the value comes to be equal to 128 in intensity. So that's why it's a bit brighter. And the calculations are already explained in the intensity versus exposure tutorial in the channel. So let's check that out. So now let me just do the color as well. So if you change the value in color, that also increases the light intensity and changing the hue and saturation of the light will change the light color. So you can see that. So that is the basic brightness and color attributes of the light. Now let's see what happens if we move, rotate, and scale the light. So by default, if you scale this light, you can see the intensity stays similar. Only the specular's hotspot is getting bigger, because that is, specular highlights are usually the light reflected on the object's reflectivity. So the reason it is not affecting the light intensity is an attribute, which is this normalize. So if you turn off the normalize, you can see now if I increase the light scale will affect the intensity. So it is a common practice that we don't use lights without turning on the normalize option, because if you think about the intensity of the light in real world, scaling the light is not possible in the real world, because it has a physical size which cannot be scaled. The only thing which you can scale is the intensity. So that is what the exposure, intensity, and color is for. And the second thing is, when you talk about scaling the light, we do change the size of the light by putting some diffuser of soft boxes. You can see those things mainly in cinematography and photography, where they put a large boxes with diffused clothes in front of the light, so that the light gets scattered through the cloth and then it produces softer shadows, because when it gets scattered through the cloth or the soft box, the light acts as it is coming from a larger area. So that is what by scaling the light is mimicking here. So if I see the just this light here, so from here onwards, let's just focus only on the single light. So let me just adjust, because all the other attributes except from the light shape, all of those things are similar on both the lights. So I wanted to show you the comparison, because just to show you that these are two different options you have to mimic, but you can always opt to use only area light that has all the options you want to, unless you want to change the light type from here, which is not, most of the time you won't be doing this, or just as a starting point you can do that. It's up to you. So let me just change the format resolution to a vertical resolution and just move it to frame only one single light here. Now let me just go to the perspective and see. So now we'll move the light and see what happens. So area light has this option, and it is one of the few lights which affects the scene when we move the light. And also you have just seen how the scaling affects if the normalized option is turned off. And if we move the light closer to the object, obviously the light intensity will be higher, and if you move away from the object, the intensity is less. And also if you rotate the object or the light, you can see the area it affects changes. So this light will be emitting the light from the surface only on a single side, and it will be emitting the light up to a 180 degree, which means that from the area from here to here, all this area will be emitting light. So let me get it back to this. So the position and scale of the light will affect the scene, the contrast of the scene, and the quality of the shadows. By quality, I mean the shadow will be sharper or softer. So if I move the light away and increase the exposure a bit, you get the similar kind of exposure. But if you see the shadows here, let me just screenshot this and move the light closer and change the exposure back. So you can see the exposure stays somewhat similar because we adjusted the exposure, but the shadow quality changes. When we move the light away from the object, the effective scale of the light changes. Let's take an example of the sun. Sun is really bigger in size than Earth, but because it is far away from the Earth, its effective scale, which is affecting the Earth, is very small. So that is why the sunlight shadow is really sharper, because if a light is really big in size, what that will make is it will make softer shadows. That is what actually the sun should be doing. It should be making softer shadows, but since it is very far away from Earth, it acts as a smaller light. The lights that creates hard shadows are called hard lights or specular lights, and the lights which create softer shadows are called soft lights. So this is the difference what makes when we scale or move the light. And one other thing would be, if you look at the specular, let me just increase the specular roughness a bit so that I can show this effect more to you. So the specular hotspot will depend on two things. One is obviously the material specular roughness. If the roughness is 0 and the light is smaller, it will create a smaller hotspot. And if the roughness is higher, even the smaller lights will create a bigger hotspot. And also, if we scale the light, that will also create a wider or bigger hotspot, specular highlights hotspot. So sometimes when you judge a material with respect to its specular highlight, we can get confused because the highlight size of the highlight, specular highlight, depends on the roughness as well as the light. So if you reduce the light so small, it creates this specular hotspot which feels like it is a glossy surface which creates this hard hotspot, but still we can see how the specular has this blurriness because of the higher values in the roughness. So keep that in mind, that light size can affect the shadows as well as the specular highlight size. And these are the main things that can be seen if you move, scale, and rotate the area light. So let me put it back to the scale 1, and I think it is on the, let's put it back to the similar height. And let me just now go to the other attributes of the light. Let me put the color back to 0, and the next option would be attribute would be use color temperature, which changes the color either to warmer or cooler. So theoretically it is said that if it is a white light, the color of the light tends to change with the temperature of it. So higher temperatures of the light will give you cooler colors, which goes to bluish tints, and lower temperatures will have reddish color. So you can see this when you burn an object, because normally it will have the colors, the fire will have the colors in the hues of orange, red, and yellows. That is really hot even for us. And the more hotter it gets, the more cooler the color will be. So that is the theory. And let me just turn on use color temperature option. And by default, the color temperature is 6500, which is the value which mimics the white color. And if I reduce the color temperature, you can see it comes to yellow, then orange, and on the lower levels, it gives the reddish tones. And if I go the opposite way, it gets more bluer. So the color temperatures are used when you want to mimic real world colors on lights, especially the sunlight, which will mimic these exact colors in different times of day. So in the evenings, it will have a color temperatures of, maybe 4,000 or 3,000 Kelvin. So the color temperatures are measured in Kelvin unit. And in each lights, like just let's say filament bulbs and other lights which are used in photography, even matchbox or candles, it all those natural light sources have its own unique color temperature value, which maybe not visible to a normal human eye, but if it is measured with particular measurable devices, and the scientists have already measured this and they have a list of values, which what each light will have in terms of its color, what temperature it has. And this is useful for us if we want to mimic exact colors of particular light sources, if we want to use it in our lighting scenes. So let's say if we are using a lighting scene with lots of filament bulbs or tungsten tubes, you can search it on in the internet, which are the color temperatures of the tube light or candle light, and you can add those values and you will get more realistic lighting in terms of color. So let me turn it off. And then the next attribute is illuminate by default. Simply an on off switch. Turn it off, the light goes off. Turn it on, the light comes back on. And Arnold is again bugging. So let me just update the scene. Now the shadows are back. Light shape. Currently we have the quad shape, and you can change that to cylinder, which creates the shape of a cylinder, which will be useful if we want to mimic tube lights, which has this shape. So here we can also change its scale as well. So if you see, if I am trying to scale this in a particular axis, it's scaling overall only. So I think Arnold doesn't have the option to scale and change its circular shape or cylindrical shape in and deform into an oval kind of shape. So I think it doesn't have that option. And another option or light shape will be the disk, which creates this circular shape. And the advantage of this will be that it will create a hotspot which will be in circular shape. So let's say if you want to mimic a sunlight, you can put this light in a very long distance from the scene, which will have less decay. So the sunlight doesn't have a decay because it is coming from a far distance. And the area light, if it is closer to the object, will have that effect, a decay effect on the object. But if we are moving it further away from, like a far away from the object, the decay will be barely visible and you won't notice the difference. So it can act as a directional light if we want to use it that way. So coming to talking about mimicking other light sources, the advantage of area light compared to any other light is that in the color you can add textures. In order to add the textures, you just click on this checker box next to the color attribute and then click on it, create a file node. And if you have any texture, so it doesn't have to be light textures, you can add any images onto the light and it will act accordingly. The image will project onto the light surface. If the light is not square, it will stretch the image into the aspect ratio of the light's width and height. And then whatever the pixels colors are, the image pixel colors will be projected on as a light color to the scene. So let me quickly connect an HDRI, not the HDRI, an area light texture. So these are all the textures that I have downloaded freely from HDRI Light Studio website. So I'll put the link in the description. You can also download this to use it So you can see these are all like textures, and the advantage of this is that it comes with option to have an alpha channel, so that whatever these areas which are seeing as a black won't be visible in the light, because the alpha channel will be excluding all those areas from the light. So let me just take a light which has a good texture. So let me just take this one, and let's see if it is working on the quad light. So I'm guessing the disk light doesn't support the textures because of the shape it has. It is circular, so the Arnold still doesn't have the option to project the texture in a circular shape, and I think they need to improve it. So let me come back to quad light, and you can see the light color has changed because we have added this light texture. So let me just quickly go back to perspective view, and then by default visibility of the camera on the light is off. If you enable the visibility, you can see the light in the render. So you can see the light source. Let me just decrease the exposure a bit so that you can see the light texture clearly. And you can use this option. Let me put the scale back to 1 and go back to camera 1. Increasing the exposure again. So that is the light shape and how you can add textures on the light.